Hello and welcome to all students. This is F5 Become Semester 2nd class Mathematical and Statistical Techniques 2nd Unit number 4 Annuity and EMI. In the previous lecture we studied about what is meant by annuity. Now in this lecture we study about what is mean by EMI. Okay, so EMI means equated monthly installments. So let us try to understand the concept of EMI. Suppose a person has borrowed some money in cash or kind which he has to return with interest in a stipulated time in equal monthly installments. Our job is to find the size of his equal monthly installments. This is the example of an annuity. This is an example of an annuity in which the person in which the present value, the sum borrowed is known, and we find the size of the periodic payments, or we call it is installments. We learn two methods to find the size of the installments. The first one is obviously based on the formula for present value of an annuity. So let us write the first method. First method to find the monthly installment. Method 1, interest or reducing balance method, and this method is called as interest on reducing balance interest on reducing balance method. Okay, and the second method is flat interest rate, a layman's approach. Okay, so let us study this first method to find the EMI using the formula of annuity. Observe that the problem is an annuity on monthly basis, and we have already learned the formula for its present value, namely we write the formula. The formula for present value in case of annuity is P is equal to, that we have learned previously, P is equal to P is equal to R into bracket R into bracket 1 minus 1 plus R divided by 12 times 100 and whole bracket raised to the power minus 12n and whole divided by r upon 12 into 100. Okay, so this is formula for present value of an annuity. Present value in case of annuity. Here P denote the present amount, or what is P here? P denote the amount borrowed. The borrowed amount borrowed. Okay, the monthly payment, capital R, denote the monthly payment. So we call it is equated monthly installment. Equated monthly installment. What is R? R denote rate of interest, and N is, in this formula, N is the duration in the year. Duration in year. Okay, so we have all these things, and therefore what happens with 12n? What is this 12n? 12n is total number of monthly installments. Okay, total number of monthly installments. Total number of monthly installments. Since P, R and N are given, we can find R, which is the required equated monthly installment, and that R can be written like this. From the above formula, we can write this R. So formula for R will be R is equal to, here I am writing R is equal to P into R divided by 12 into 100, okay, and whole divided by 1 minus 1 plus R divided by 12 into 100 and whole bracket raised to the power minus 12n. So this formula will give us the monthly installment. Okay, monthly installment, or EMI. Okay, equated monthly installment. So we observe that though a lot of calculation is required here, this is a better and more accurate method, since it is the formula of annuity, which is a properly documented mathematical concept. In spite of all the monthly installments being equal, the annuity formula automatically takes into account that every month a certain sum is paid automatically takes into account that every month a certain sum is paid towards the debt. Hence the balance amount left for clearing the remaining debt is reducing recursively as a months pass by. Hence, this method is called as interest on reducing balance method. Okay, so based on this method, let us try to solve some examples. Let us write first question number 1. Okay, question number 1. A person borrowed, so write question. A person borrowed, BORROWED, person borrowed rupees 10,000 at 12% interest per annum. Interest per annum. Okay, full stop. If he is supposed to return, if he is supposed to return, if he is supposed to return the monthly, the supposed to return the money within 2 years, the money within 2 years, money within 2 years, find his EMI, find his EMI. That example is very useful in the real life situation for all of us. Okay, by using method interest on reducing balance, using method interest on reducing balance. Okay, so let us go to try to solve this problem. Let us write the answer. Let us write the answer. So we know the formula to find EMI. So formula for EMI, so formula for EMI is given here. R is equal to P into bracket R divided by 1200 whole divided by 1 minus 1 plus R divided by 1200 bracket raised to the power minus 12n. Okay, so in this formula we put the values of all parameters. So here the value of P is equal to P means the person has borrowed the amount, it is of rupees 10,000. and the rate of interest R is 12% and N is equal to 2. For 2 years that amount is borrowed. So if I put the values of all these parameters in our formula, then R will be equal to here P is 10,000, okay, into 12. So R is 12 divided by 1200 bracket complete whole divided by 1 minus 1 plus R is again 12 divided by 1200 bracket complete whole raised to the power minus 12 into n is 2, okay, bracket complete. So if we solve all this thing, so try to solve this, try to simplify this expression, and after simplifying what we get is okay, in the numerator there will be only 100 whole divided by this is 1 minus 1.01 raised to the power minus 24 bracket complete, it is equal to, and if we simplify this term we get 470.7353.2. Okay, so this is R. So this gives the EMI monthly equated monthly installment. Okay, so based on this method let us take one more example and you try to solve this example at your own. Okay, so write down question number 2. A person bought a TV worth rupees, so I'm not writing all these terms here, so I'm writing only the values. A person bought a TV worth just 7,920, okay, of which he paid how much rupees? 2,920, and he paid 2,920 rupees. Okay, so now our P will be, this is P1. Okay, so our P will be now 5,000 rupees. Okay, and the balance was to be paid, means this balance, okay, was to be paid within 1 year. So N will be 1 year, within 1 year in equated monthly installment. Okay, if the rate of interest R is of rupees 10%, and find EMI. EMI means we have to find the value of R. So this is homework for you. We have given all these parameters. P is equal to 5,000, N is equal to 1, R is equal to 10, and what we have to find is our monthly installment. So I will give the answer here. So answer is, so this is answer by using method interest on reducing balance. Okay, interest on reducing balance. So answer is 76 rupees, 76.9098 rupees. Okay, but you try to solve this problem at your own, and this is homework for you. Okay, so this is the end of this lecture. Thank you for paying attention. Thank you very much.